Imagine that your home is 160 million kilometers from Earth. The first human settlements have been built in another part of the solar system. And you are one of the pioneers. You'll live and die here. Welcome to the future, off the home planet. The year is 2050 AD. The moon now has a large human population living underground and in craters domed over to enclose living, breathing Edens.
A 100 years from now, when my grandchildren go to visit someone on the moon or go there to live, they won't live in lifeless, airless, sterile tin cans any more than we would want to live that way. They're going to live, you know, in a beautiful park with 600-foot tall trees and be able to fly like birds themselves.
Life imported from the Earth will be just beginning to take hold on a planet where it hasn't rained for almost 4 billion years.
Now we imagine Mars. On Mars, nature, as we found it, is barren, and we have a chance of introducing life. And so when I imagine Mars today, that's a beautiful and a very interesting world, and I would want to study it deeply. But when I imagine Mars with life, I find that more interesting and more valuable in some deep sense.
Later still, the city builders have started work on the Martian surface, creating a new home for colonists who've made the biggest one-way journey of their lives.
When you go to a new place like Mars, and you establish a new branch of society there, you have an option to take with you the best ideas and then leave as much of the worst behind. And the people that settle Mars will not want to return to Earth. They will want to live on Mars and develop their future there, or perhaps even further out in the solar system.
In the late summer of 1976, 2 identical Viking craft soft-landed on Mars. The Viking mission was the first to send back a detailed picture of the surface of another planet. Although it didn't find the evidence of life it went looking for, Viking did succeed in carrying out valuable experiments on Martian soil and air. It was a scientific triumph. But Christopher McKay is a NASA biologist who believes that space science is merely a way of preparing for something far more important.
Space exploration is often discussed as if its only objective was science. If one takes that approach, then certainly sending humans to space is not cost effective. We can get better science with robots and robotic probes. But I think that misses the whole point. Why are we doing science? Why are we exploring space scientifically? Well, I think it's part of a broader human activity, part of a broader human enterprise in anticipation of human settlements. The planet, it's the closest, the easiest in the sense of being able to be our first step is Mars. You're not sending humans to Mars as a tool to do science. We're sending humans to Mars. One of the things that they'll do when they're there is science. They'll also write poetry, and they'll also cuss and scream and all the other things that humans do.
Viking mission was designed to last only 3 months, but the orbiters and landers sent back a stream of data for 6 years, including over 50,000 photographs covering 97% of the Martian surface. Yet McKay thinks that even for scientific work, robots like Viking are ultimately no substitute for human missions.
People talk about sending robots to the other planets to explore and never needing to send humans, but I find that very uninteresting. I equate it to maybe going to Paris, but instead of actually going to Paris oneself, just sending a camera there, getting pictures taken, bringing the camera back, developing the pictures, looking at the pictures and thinking, well, that was great, I've done Paris. I think that the human presence, the human experience is part of the motivation for going, and eventually humans will want to go to these other worlds.
But why would you take the next step and build human settlements on other planets? Robert Zubrin is a space engineer who's proposed a way of sending the first humans to Mars. But he doesn't want to stop there. For him, Mars in the 21st century is the frontier, a place to be settled by colonists from Earth.
The frontier on Earth is closed. I think that unless humanity is going to move into an age of stagnation, we have to be willing to embrace a new frontier, and the new frontier that's out there is that in space, and particularly on Mars. What settling Mars is fundamentally an act of creation. That what we will be doing is creating a new branch of human civilization, a new branch of human culture. In other words, we are not doing this for us. We are doing this for them. We are doing this for the Martians.
Is all this possible? Much of the technology to do it was developed in a period of a little under 10 years that started in the late 1950s with animals sent into orbit in ballistic missiles. This chimpanzee was to make it back safely. But at the time, little or nothing was known about whether humans could survive in space. Yet by the early 1960s, President John Kennedy believed the greatest prize of the decade was within reach. The wagon train to space was about to leave.
Many years ago, the great British explorer George Mallory, who was to die on Mount Everest, was asked why did he want to climb it. He said, because it is there. Well, space is there, and we're going to climb it. And the moon and the planets are there.
In 1962, Kennedy gave this speech at Rice University that it still echoes down, you know.
Because that goal will serve to organize and measure the best of our energies and skills.
This is probably the most brilliant speech of American political oratory in the 20th century. It hits it right on the nose. It's that you have to be willing to accept challenges like this, okay? You have to do that if you're going to grow, okay? And Kennedy and his generation were willing to do that.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
We choose to go to the moon not because it is easy, but because it is hard. It is an act of faith and vision because we do not know what benefits await us, but space is there and we are going to climb it.
The space program became a high point of 20th century optimism, an intoxicating mixture of white-hot technology and human daring that made anything seem possible. First the moon, next stop, the stars.
What were the benefits of Apollo? certainly wasn't the acquisition of a couple of 100 pounds of moon rocks. The real benefit of Apollo was a generation of youth that were inspired to enter science by the offer of the prospect that they could become part of a great adventure of the human pioneering of space. And I know that for a fact. I was one of them. I was 9 when Kennedy gave a speech calling for sending us to the moon. I was one of Apollo's children.
Human ambition was soaring on top of the most powerful rocket engines ever built. And other children of Apollo were having their imaginations rewired by a new future in space. Children like Marshall Savage.
For me, I think the key moment in the whole idea of man in space came with the first orbital flyby of the moon. Somehow that impressed me more even than the moon landing, because it was the idea that these are the first guys who went into outer space. They left the Earth. They weren't just flying in orbit. They were out there in deep space.
Happy birthday, brother.
My family and I had taken a year off and were traveling around Europe in a Volkswagen van. I think we were the first yuppie hippie family in history. And we were on the island of Rhodes, Christmas Eve, 1968. Terrible weather, rain pelting down, absolutely black outside. We were all jammed up in our own little life support capsule there. And we were listening to the radio, these guys, these men, the first true spacemen, and their voice coming disembodied from the depths of space. And I didn't grow up with a religious background, but when they started reading from the book of Genesis, and you're listening to these guys on Christmas Eve out there in the depths for the first time.
In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light."
It just touched me and a vital chord that said, this is the future. And not just the future of mankind, but your personal future. These guys are talking to you.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
As Apollo 11 left for the moon on July the 16th, 1969, Kennedy's Mount Everest was about to be conquered, just 8 years after he first announced the race to the lunar surface.
Tranquility Base here. The Eagle has landed. Golly, this time goes fast. Wow. Sorry, Charlie. Beautiful. I gotta keep my arm and drive. I was rolling on the moon one day. In the very month of December. May, that's right. Off the ground, up north. There we go. What a ride, what a ride.
But as the astronauts of Apollo 17 left the moon on December the 14th, 1972, the momentum to carry people further out into the solar system was lost. Since then, no one has broken free of the Earth's orbit.
on Mars already. If we had continued the space program in the vein of the Apollo of the late 60s, we would have had our people on Mars by 1981. We had the capability to establish people on the moon right then. We had 85% of the capability we needed to establish people on Mars, and they burnt the fleet. It's as if Columbus had come back from the New World, having made his discovery, and Ferdinand and Isabella said, well, so what? Burn the ships.
In high schools and colleges across America, tens of thousands waited to fulfill their ambitions as astronauts. For them, space was the future. By his late teens, Marshall Savage was convinced he would be signing up for the next and far more dangerous adventure beyond the moon.
Basically, I just wanted to go to Mars. I didn't care if I was the first or the 50th or the 5,000th. I just wanted to go to Mars. That seemed like a noble and attainable ambition given those times. There's going to be a 100-man permanent space station in orbit, a permanent colony on the moon, and men on Mars in the early 80s would fit my schedule perfectly. Well, history took a very different turn. The whole post-Apollo space program was all scrapped and we weren't going anywhere. So I didn't know where I was going or how I was going to get there, and sort of shuffled off to a little college in Pennsylvania called Swarthmore, disillusioned with that whole idea and looking for something else. And lo and behold, who should show up to talk to the astronomy department but an old Swarthmore alum named Gerard K. O'Neill. And this guy comes in with his slide presentation, putting up slides of space colonies the size of cities, and that, of course, relit my candle.
If we go into the time frame that might be even as early as the 1990s, I think we may see the first of the medium-sized spherical habitats, several hundred meters in diameter and with a circumference which might perfectly well be as much as a mile. And interestingly enough, in scale, not that different from some places which humankind has traditionally regarded as very attractive, like the island of Capri or the town of Carmel, California, or the nicer bits of London, or whatever your favorite spot happens to be.
O'Neill was a brilliant and respected physics professor at Princeton University in New Jersey. But his wife, Tasha, remembers how his passion for space colonies began in classes he gave for students who had no background in science.
He was teaching a new course for students who were not really interested in physics, but they had to take this obligatory course, and it was called Physics for Poets.
As the first men were landing on the moon in 1969, O'Neill began, almost as a joke, to ask his students a question about leaving Earth altogether.
In the long term, is the surface of the Earth really the right place for an expanding technological civilization?
Is a planetary surface the right place for an expanding civilization? And the answer turned out to be no.
O'Neill wanted to build his space cities in an orbit between the Earth and the Moon. He called this place the High Frontier. But first, he had to get his idea taken seriously. It would take him 5 years, and happened almost by accident after a public meeting in Princeton.
Jerry decided it would be nice to get, well, as many people as were interested together. And Walter Sullivan, who was then the leading science writer for the New York Times, decided that it was newsworthy enough, and they put it on the front page of the New York Times, which instantaneously changed our lives.
But his dream of living in human colonies turning free in space never got beyond artists' impressions and models. He died of leukemia in 1992. In the 30 years since O'Neill first proposed orbiting space colonies, a new idea has emerged: terraforming, or changing planets to suit human habitation. Marshall Savage believes that our desire to colonize other worlds and to make them like our own is ingrained in the human psyche.
Human beings are programmed with a deep need and love for the natural beauty and splendor of the home planet. The trees, the flowers, the waterfalls, the birds, the butterflies. These are the things that really move us, and that will characterize the human experience of space colonization from here on out. And the thing that will astonish people, I think, is how naturalistic and Earth-like, really Eden-like, that form of life will be.
Savage thinks that the moon is capable of sustaining large human settlements. But how do you create an Earth-like world for people to live in on a place as barren and airless as the moon? One way is to transform craters into biospheres, self-contained islands of life. Under domes made of silicon and water would be oases of plant life imported from Earth. People living in the moon's gravity are only 1/6 of their weight on Earth. So in these lightly pressurized domes, a primordial dream might become a reality.
At 1/6 gravity, a human being can fly under his own power. You suit up and you strap on your gossamer wings and launch off the branch of one of these gigantic trees. You can stretch out your own wings, and by flapping your own arms, actually propel yourself through the air like a gigantic bird.
The moon is known to be rich in raw materials like iron and frozen water. Enough of everything for Marshall Savage to believe that industries could be built on the moon.
Once you've got a toehold on a place like the moon, growth there can be very rapid. And there will be several centuries of just rip-roaring, rootin'-tootin' industrial activity on, the Chicago of the future, the little planet of the big shoulders, as people produce industrial infrastructure hell-bent for leather on the moon.
Beyond the moon, the prime candidate for human colonization is Mars. But it's a forbidding place. The average global temperatures are -60 degrees Celsius, and at the ice-covered poles, it can drop below -130 degrees. But there is evidence that Mars was once a wet, warmer planet, not unlike the Earth. Scarring on the surface suggests that rivers and seas had once existed. So where did the water go? Some is locked up in polar ice, but it could be that water is also trapped beneath the surface. Mars has other ingredients, too, that would make terraforming possible, and not just within the confines of a few domes, but the entire planet.
Mars has all the resources needed to support life. They're on the surface in some accessible form. Carbon dioxide, water. It's frozen now, but one can imagine melting it. Nitrogen's there, sunlight's there. All the resources needed to support a biosphere, and maybe even to make a self-sustaining planet, are there. Then the next challenge is to warm up the planet and get these materials from their frozen, cold state in the surface out into the atmosphere again. And interestingly, we've learned how to do that on Earth. We are releasing into our atmosphere super greenhouse gases that are thousands of times more effective than carbon dioxide at creating a blanket around the Earth to keep it warm. Now on Earth, that's probably not a good idea, but on Mars, that's just what one would need to make Mars warm and melt the ice and bring all those materials back into the atmosphere.
To make these gases, you need carbon, hydrogen, chlorine, and fluorine. All of them may be available on Mars. They could be mined on the Martian surface, mixed in robot factories, and then pumped out of chimneys in huge quantities. They would trigger a runaway greenhouse effect. The polar ice caps would melt, and the Martian surface would be transformed into something that looked very Earth-like. Great oceans and lakes would appear, and the atmosphere would start to thicken and change. The average surface temperature of Mars would rise from -60 degrees to just above freezing.
Having warmed it a little bit so that there's water on the surface, a thicker atmosphere, one could then introduce very simple ecosystems, not unlike the ecosystems that exist in the Antarctic and Arctic regions today.
The first plant life to take hold out on the Martian surface would be little more than algae. But it would be the advance party for the greening of Mars.
Our calculations suggest that Mars could become warm with a fairly thick atmosphere on timescales of 100 years or so. It's remarkably efficient once we start trapping solar energy. And as the atmosphere got thicker and the planet got warmer, more and more sophisticated advanced life forms could be introduced. And Mars would recapitulate the evolutionary history of the Earth, only it would do it much faster because it would have the biology of Earth to help jumpstart. It's possible that if Mars was warm enough, maybe in 100 years or so, that there could be real forests, one can imagine pine forests like one sees on the side of a mountain, growing on Mars.
For Christopher McKay, bringing life to Mars is an obligation placed upon humans as a unique, intelligent species.
I think that life in the microbial and simple forms should be on any planet that has liquid water and even remotely similar to the Earth. So I think life is commonplace. Intelligence, I think the case is much weaker. In fact, I would be willing to argue that intelligence is rare, maybe even singular on Earth. I think it would be a mistake to give up our intelligence and to act like just another animal. We should say, what is our role as the intelligent member of this community? What can we do to help contribute? And I think the answer is spreading life, taking life from its planet of origin here on Earth, taking it beyond, and we as an intelligent species are uniquely capable of doing that. It's a task worthy of us as a species. It would be like building pyramids and cathedrals. It's something that we could do as a gift to the rest of the universe.
Robert Zubrin has devised a way of getting the first humans to Mars relatively cheaply. Known as Mars Direct, it's an idea that's been adapted by NASA.
We use the same technique for exploring Mars that pioneers have used on Earth, which is travel light and live off the land. First launch, You launch to Mars an Earth return vehicle with nobody in it. Flies out to Mars, takes 8 months to get there. You landed on Mars, and then you run a pump, and you suck in the Martian air, which is carbon dioxide gas, and you react that with a little bit of hydrogen that you brought from Earth to produce a very large supply of methane, oxygen, rocket propellants. Now you got a fully fueled Earth return vehicle waiting for you on the surface of Mars. You shoot out the next booster, and that fires the crew out to Mars. And because the return ride is waiting for them on Mars, they don't have to fly to Mars in a gigantic Battlestar Galactica spaceship. They land that on Mars near the Earth return vehicle. They use that as their house on Mars for a year and a half. And at the end of that time, they get in the Earth return vehicle, they take off, they fly directly back to Earth. They leave their hab behind on Mars. So each time you do this, you add another hab to the base, and gradually, we build up the beginning of the first human settlement on a new world. So now you'll have a situation, perhaps 50 years from now, in which we will know how to be self-sufficient on Mars, in which you can get to Mars relatively cheaply. And at that point, I believe that large-scale emigration to Mars will begin. Who will do this? Well, it could be people seeking adventure. It could be people who are driven there as refugees. It can be people who are members of a religious sect who find that they need to have a place where they can go, where they can make their own world. Once it becomes possible to go, people will go. I believe that within 50 years after that, you'll probably have more than 1 million people living on Mars.
I would like to live by the water and within sight of mountains. For instance, on the shore of the sea filling the Hellas Basin, you would be next to a body of water like the Great Lakes or the Mediterranean. And then right next to it would be an entire range of mountains that you would have off to the west.
From his home in Northern California, science fiction writer Kim Stanley Robinson has imagined what human life would be like on a terraformed Mars. But one inspiration for his novels came from the images of a spectacular wasteland beamed back by Viking.
I got interested in Mars as a matter of wilderness, that I'm interested in spending time in the mountains above treeline and in the deserts of the American West. And so when the Viking data came in, what they showed is that Mars is a spectacular landscape, and these features drew my interest. And I thought this would be a great place to go backpacking.
Viking revealed Mars to be a tourist dream. Valles Marineris is a 4,000-kilometer-long chasm that's up to 8 kilometers deep, 200 kilometers wide, and nearly 10 times bigger than the Grand Canyon. Olympus Mons is an extinct volcano that rises 26 kilometers above the surrounding plains. It's almost 3 times as high as Mount Everest. For all its variety, Mars today is a huge empty desert. Should it stay that way? Robinson foresees an environmental battle between advocates of an untouched red Mars and those of a living green Mars.
The red-green conflict in my novels has to do with the idea that there will be people who fall in love with Mars as it is right now. And the idea of terraforming it would be, to them, a kind of desecration. On the other hand, it would be a lot easier to live on Mars if we alter it to give it an atmosphere and less deadly. So the greens and the reds, I believe, will come to exist and will come into conflict.
Sooner or later, Mars will be literally terraformed, and it will be possible for people to live on Mars in the outside in the same way they do on Earth, except that they'll only have 1/3 the gravity.
Wherever humans choose to live, On the Moon, Mars, or beyond, one thing is certain. If they stay permanently, their physical appearances will be altered by different gravitational forces, sunlight, air, and other influences.
Just the occupation of those kind of environments is going to change the people who live there into almost entirely new and distinct species. After 1 or 2 generations at the most, for example, people who are native to the Moon are apt to be several feet taller than people who are native to the Earth. If they don't bother to go through the considerable trouble of maintaining the skeleton and muscular infrastructure they need to support against one gravity, and basically say, well, I live on the Moon, and, you know, I'm never going to Earth except by video tour or by holographic goggles anyway, you know, I'm going to be a lunarian. Well, these people are going to grow very tall and very slender with a minimal musculature. And after a number of generations of that, we may literally find that the genotypes evolve in their own special directions.
To predict what would happen over many generations is beyond science. You would need to be a latter-day Leonardo da Vinci even to imagine the appearance of the most far-flung and isolated colonists.
Ultimately, where we're going with this is the true Star Trek universe. You probably noticed that in Star Trek they fly all over the galaxy and they meet all kinds of alien people, but they all have basically 2 arms and 2 legs and some funny stuff on their forehead. Well, I think in a few thousand or a few million years that will be an accurate picture. But the reason is because all of those species had their original root stock in the Earth, and then, depending on their home environment, they will follow a genetic line completely distinct from almost anyone else. All with a common origin, but otherwise as distinct as Vulcans and Klingons.
We're going to be introducing variation into the human species. The Earth has become too small to maintain human cultural diversity. In nature, diversity is the key to species survival. And I believe this is how humanity will both maintain and, in fact, expand its diversity as it expands into the cosmos from here.
It could be that the exploration of space is inevitable. We talk about humans and their natural curiosity and sense to explore, but this could be a more fundamental property of life itself. Life can be a phenomenon that, like a fire, for example, must constantly grow in order to maintain itself. It constantly has to be burning at the edge for a fire to maintain itself. Life can be that way too. It might need to constantly be expanding and growing into new frontiers in order to just stay alive as an overall system.
What's humanity all about? What is our great striving all about? What are our epics all about? Our religions, everything. They're about a quest for immortality. Immortality through gods or deities, or immortality through acts of immortal importance, whether they are the settling of the West or the settling of Mars. And this is more important than bread. This is what people will fight for. This is what people will die for. And this is what will send us into space.
I believe the only way that we're going to get out into space is by making space pay. If you want to go to space to stay, space has to pay.
In Steamboat Springs, Colorado, Jim Benson is planning how to make money out of space.
Back in 1990 or 1991, while I was reading the Washington Post, I came across a little article, Asteroid El Dorado Found in Space. And it turned out that it's a solid ball of stainless steel worth $80 trillion. I thought, well, if this one asteroid is worth $80 trillion, maybe I should find out if there are more like it, or what the story is.
Nearly 500 asteroids have so far been discovered passing close to the Earth's orbit. Little is known about them, but they could all be immensely rich in minerals.
I was first fascinated by the metallic asteroids because they have very high concentrations of gold and all of the platinum group metals in them. But when you think about it, they would be extremely hard to mine. It would be bumping up against a mountain of stainless steel, and chipping away or drilling that would be very difficult.
But Benson realized that a few asteroids contain something even more valuable than precious metals: ice, which could be turned into water and hydrogen separated from it to make supplies of rocket fuel out in space. Without the huge cost of lifting fuel from the Earth, colonizing space would become a more realistic proposition. So Benson set up a public company to build a small probe designed to go prospecting for ice on the asteroids. He wanted something that would be reliable and cheap.
One of the key aspects of our near-Earth asteroid prospector is that we're not doing anything new. All the technology that we're using has been used before. It's trailing edge technology. This makes it better for the investor because we can do it cheaper. I'm going out to do this to both open up space for humanity, but also to make money doing it. I believe that commercial enterprises can make money in space, and once we do it, then everybody else will see that it can be done, and that'll open up the vision of the future for all the people who want to go out and build space colonies and mine the asteroids and live on the moon and Mars.
Jim Benson made his first fortune in the computer business. He's convinced he's going to make his second in space.
If we look back 20 years ago at the beginning of the PC revolution, no one knew that was happening, no one knew who the winners or the losers would be. But today we have more billionaires than you can shake a stick at. We're at the same place with space commercialization today. Anything can happen, and most things will.
How far can humans travel to colonize space? The real limits may not be technology, but our own mortality. We simply couldn't live long enough to get anywhere beyond our own solar system. But even this could be overcome if we could design something that traveled fast enough.
I'm not sure where the ultimate horizon of human limitations is. I believe that travel to the stars is possible. We understand all the fundamental science that is needed to create an interstellar craft. We understand fusion reactions, which give us a basic form of power that, once we work out the engineering of how to do it, will allow us to develop ships that are capable of getting up to perhaps 10% the speed of light.
But even with a spacecraft that traveled at that speed, it would still take over 40 years to reach the nearest star system.
I think there's a realistic cutoff in terms of what makes interstellar travel feasible. Look at it this way: the fastest human beings have ever traveled was during the Apollo program. At that speed, getting to the nearest star would take you 1,000,000 years. So you have to go at enormous velocities, otherwise it's going to take whole millennia, thousands of years to get to the nearest star system. Now, there are proposals in science fiction for doing that, building these gigantic world ships with thousands of people living in self-sufficient communities for thousands of years. But if you did that, I guarantee by the time you got to the nearest star, there would be a new civilization that had already grown up at that star, populated by people who stayed behind using the industrial capacity of the home star system to build antimatter rockets or something really good that moves at 50% of the speed of light. They would have flown out there in a mere 8 years. They would have built up an entirely new solar civilization while you were still in transit. So by the time you got there and got off the world ship, you'd be like some fossilized Rip Van Winkle, and you might get a slot on a morning show, but that would be about your only impact on that solar civilization. So if you can't go fast, stay home.
From 1969 to 1972, a selected few left home. 6 Apollo missions landed on the moon. Just 12 American astronauts.
Wow, what a place. What a view, isn't it, John? It's absolutely unreal. How about rolling that one over? No way. You do that in West Texas and you get a rattlesnake.
Memories of a 20th century triumph still haunt those who expected and hoped for so much more. It's as if it all happened yesterday. But these images are a quarter of a century old.
Oh, dadgummit.
Will humans come this way again? And this time, will they keep going?
The stars are within reach, provided we don't give up now, provided we don't give up on becoming a spacefaring civilization.
We're going to be well entrenched in the stellar environment. There will be 50 growing civilizations out there in the sky. You can walk outside at night on the Earth and look out in the sky and name physical places, real geography in the night sky of the stars that are inhabited and the kind of people who live there. And that's going to happen in just the amount of time that's separating us from the Vikings.
More than 2 decades after it arrived on Mars, Viking has been battered by dust storms into an eternal silence. If the human colonization of space doesn't happen, Viking and other craft like it will become lowly memorials to a failed dream.
Mankind among the stars, that's what we were born for. That's where we were going.
Left to go to the moon. This one right here? That's it. You got it right there.
Does life on Earth spring from Earth, or are we the result of microbes from Mars? It came from outer space. Another Discovery premiere showing next.
Absolutely incredible. Now I tell you, I can't see to the bottom of it. I'm as close to the edge as I'm going to get. That's the truth.